having a good time.
Marcus isn't watching this. I'm sure he's not. All right, section 2.1. I don't know who's watching this, but this is section 2.1. We're going to go through this all at one shot because it's really short, even though it looks like there's like kind of a lot of examples. But anyway, quadratic functions. A quadratic function is of the form y equals x squared, right? Y equals x squared, and y equals x squared is a parabola. We know that. That's stuff we should know. A quadratic function is just one type of polynomial function. The polynomials are like linear functions and quadratic functions and cubic functions and quartic and quintic and blah, 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 and all of those. Those are all the group of polynomial functions, so quadratics is just one subset of those, okay? So they have examples down below here. And like this first one is an example of the standard form of a linear function, right? Ax plus b, that's linear, right? Yeah. Do you know what the middle one is? Where it's just f of x equals c.
A line.
Where c is a number. It's a line. This would be like f of x equals or y equals 3, right? That's a constant function. It's just going to be a straight line, but it is horizontal. So like y equals 3 would be 1, 2, 3, and a straight line across. Whatever, right? So that's still considered a polynomial function, and then this one's x squared, so it is a quadratic. What?
What would it look like vertical?
Vertical? Vertical would be x equals something. Now, usually, I mean...
F of x equals something to make it vertical?
No. F of x is always standing for y. X equals something. We... Like when we talk about axis of symmetry, okay, so for a quadratic function here below, we're going to be talking... Let me move him over to the side. Okay. When we talk about an axis of symmetry, that would be like the line that goes down through the parabola. And let's say this is at like 5. This would be the equation x equals 5, right? Because that's a vertical line. And he goes through the x-axis at 5, so x equals 5. Now, we usually only talk about like x equals something or a vertical line in relationship to axis of symmetry because the actual function x equals 5 is not a function, right? Because he doesn't pass the vertical line test. So we use x equals something to define like axis of symmetry, but we don't actually do that as a function itself, like by itself a function, because it's not a function. So that's kind of like why we don't talk about vertical functions a whole lot. That makes sense? Or vertical lines a whole lot. Anyway, all right, definition of a quadratic function. I call this standard form. That is not what they call it, but I call this guy standard form because every other textbook calls that standard form of a quadratic function, okay? It has an a, a b, and a c value, and we've seen those before, like when you do the quadratic formula, which was...
What's this?
What? What?
This thing.
That thing? Oh, that's like the equation of a poly. So like a sub n would be a constant. So this is a number and x to the nth power. So let's say n is 7, right? Then we have another number, x to the n minus 1, which would be the 6th power. And we have another number, x to the 5th power and 4th power and 3rd power. And then another number, x to the 2nd power, another number, x to the 1st power, and then a constant number. So they're just using those like a sub n and a sub 1 and blah, blah, blah. So those are just terms. That's just like their notation that they write, which is kind of weird. So all your a's are going to be integers, and all of your x's to the nth power would be your terms, I guess, or whatever. Anyway, that's just the notation that they use. All right, so quadratic functions. All of these in this example are quadratic functions. The first one is standard form. So is the third one. And so is the fourth one. These are all standard form. Standard form, okay? The second one is in what's called, I call vertex form, okay? And the reason why I call it vertex form is because you can easily find the vertex from that, right? So like if we think about like transformations, right? This plus 1 is moving him to the left 1, and the minus 3 is moving him down 3, okay? So that parabola is going to the left 1 and down 3, and he looks like this. And actually this 2 is not changing where his vertex is, it's only making him skinnier, right? So the vertex form, I call that vertex form because you can easily see in the equation the vertex is embedded into that. Does that make sense? Okay, when it's in parentheses like that. X plus something squared and then minus something. This is your up and down, this is your left and right. And that tells you where your vertex is located. So this vertex would be at -1, -3. You flip the sign of this one, but you leave this one the same, right? This guy is, I call it factored form, because he's factored down, okay? factored form, and he is really nice. He is harder to find the vertex from, but what's easy to find is if I set these guys equal to 0, like x equals 2 and x equals -1, those are going to be where my zeros are. So when it's in factored form, I can find the zeros of my parabola really easy. Does that make sense? So each one of these forms has a specific like reason for us writing it that way. Hold on. You have questions?
Yeah.
Come back in like 10 minutes. Can you do that?
Okay.
Okay. So each one of these forms has a specific thing that they're like a certain aspect of it that's easy to find. Like vertex form is easy to find the vertex. Factored form, it's easy to find the zeros. Standard form is actually easy to find the y-intercept because the y-intercept is always going to be that last number. So anyway, that's those are like the special qualities about those guys. All right. Okay, every quadratic function is going to look like a parabola, and each one of them is going to have an axis of symmetry and a vertex. Okay, so the vertex, I'm just going to give you a little hint. Not yet. We'll get to that backside. Okay, so a parabola is going to face up if it's positive and down if it's negative. Do you know what I'm talking about with that? Like if your a value, so like this would be like x squared plus 6x plus 7, something like that, right? Where this x squared is positive. This might be like -2x squared minus 4x plus 1. I don't know. Something like that. And he's going to face down because it's negative, right? So examples of that, just like if it's a positive x squared or a negative x squared, he's going to face up or down. If he faces up and he's a smiley face, he is going to have a minimum right here. His vertex will be a minimum. If he faces down, he's going to have a high point and his vertex will be a maximum. That just makes sense, right? Minimum versus maximum. That's how that goes. Okay? All right, on the back side, they're going to actually have us find the vertex. So here we go. Oh, wait, before we do that, sketch the graph of the function. So if our parent function is x squared, they're saying, like, what do some of these things do to that graph? Okay, if our parent function is x squared starts at 0, and he's just a parabola that goes through, like, this is what the parent function looks like. Okay, versus this guy, a. What is happening to a? I'm going to sketch him over here.
Flipped.
He's flipped down, so he's over x.
Do it right there.
Yep, sure. Over x, and what's the plus 1 do?
Up 1.
Up 1. Okay, so he's over x and up 1. So we're up 1, and he's flipped down. That's what he'll look like.
Do you flip a parabola over the wall?
Technically you
technically,
can,
yeah,
but it stays the same. It's
does
exactly
the
the same as what it looks before.
equation
So technically it looks like this, okay?
Oh, duh.
Right? But, so this is over the y-axis, right? But if you take a negative x and square it, doesn't it just turn back to positive x squared?
Yeah.
The reason why is because when you flip him over the y-axis, he doesn't change. He stays exactly the same looking. Very, very good question. Okay, let's go to C. We'll go to C next. What does this 2 do?
Stretches it.
Stretches it, so it makes it tall and skinny. So, vertical stretch by 2. There you go. That's what he is.
What's the
Okay?
one that it's like reciprocal?
The reciprocal is when it's in, so like if it said like 2x in parentheses squared, this would be a horizontal compression by 1/2. Because the 2 is also being squared. It's underneath of the parent operation. That makes sense?
No.
It's inside the parent.
Left
Okay,
2,
sure. This one
down
is
3.
left 2 down 3. Left 2 down 3, okay? And this guy is in vertex form, right? So left 2 down 3 tells me where my vertex is. He's still going to face up and be the same shape as what he was before, but my vertex tells me, or this equation tells me my vertex is at -2, -3. So it makes it really easy to identify the vertex. Yeah? Left 2 down 3 tells me that the vertex is now at -2, -3. Good? All right, we're flying right along through this. Okay, now, this is where I don't agree with what the book says, okay? And it just has to do with their labeling. They call this standard form. I call this vertex form, okay? So if they ever refer to, like on your homework assignment or whatever, if they refer to standard form, that's what I call vertex form, okay? I don't ever refer to standard form. So like down here on number 1, or number two, write the standard form of the equation of a parabola. They actually mean vertex form, okay? Does that make sense? So standard form, this is vertex form, and you have an H and a K, right? Like that tells you your vertex, but then you also have this guy right here that could be a stretch or compression.
No,
No?
don't want to.
No? Like this is exactly what we had. I don't know.
I know. I just
I don't know.
like
You're like, I don't like that. It's fine. It's not that bad. Yeah, so like G right here had that 2 out in front that was a vertical stretch, and then it's just moved, right? So that's a thing. He's in vertex form. That's fine. Okay, to find a vertex when it's in standard form, which is what I call standard form, the vertex, to find the vertex, you do negative b over 2a. Do you remember that? Or you remember hearing that before? Negative b over 2a.
We do that trick.
Yeah,
Or is
yes,
that
we
this
just did
course?
it. We just, no, did we do, no, we haven't
Wait,
done it yet. We haven't
yeah,
done it
we
yet.
have.
Yeah, we have. Okay, never mind. We're doing it right now in my algebra class. Negative b over 2a. Now, how do you find the y coordinate after you've done negative b over 2a?
F of negative 2.
The
Yeah,
last number.
you plug, no, that's the y-intercept.
Oh.
Okay, you plug this guy back into here, and that gives you the y coordinate. So I just say plug in. Plug in. That's how you find the vertex.
For all the x's?
Yes,
Like
yes, you'll
whatever
plug it in for
number.
all the x's. Exactly. Yes, yes, yes. So we're going to do that here. We're going to, it says sketch the graph of this thing and identify the vertex and the axis of symmetry. Now, I don't want to sketch him first. I want to sketch him after I found the vertex and the axis of symmetry. So vertex is negative b over 2a. And negative b would be negative 8 over 2 times a, which is 2, right? So it's negative 8 divided by 4, so negative 2 is the x coordinate. And then I plug that in to find the y coordinate, right? So 2 times negative 2 squared plus 8 times 2, negative 2, plus 7. Okay, and then I solve that. All right, negative 2 squared is 4. 4 times 2 is 8. Okay, 8 times negative 2 is negative 16, plus 7, negative 1. That whole thing is going to be negative 1.
Oh, I missed a negative somewhere.
Okay, all right, so just to do a little sketch, negative 2, negative 1. That's where my vertex is. And his parabola is smiling or frowning?
Smiling.
Smiling. He's going to do this, right? So my vertex is there. And then let's talk about what the axis of symmetry is. I call it the AOS.
Be negative 2.
Axis of symmetry.
What is it?
Is what?
Negative 2.
Yeah, so it's this dotted line going through here. And your
So is it
axis of
always
symmetry.
your x?
Yes, your axis of symmetry is x equals something, right? And it's always going to be the x coordinate because it will always go through the vertex. So x equals negative 2. So these two numbers should always match each other, right? There you go. Axis of symmetry, vertex, there's the sketch. Perfect. Okay? All right, next to last thing, number 2. It says write the standard form, okay? And standard form, their standard form they go off of is y equals a x minus h squared plus k. That's the standard form that they use, okay? It's just from up here. That same thing from that little box, okay? That's what they call standard form. They want us to find standard form of a parabola whose vertex is 1, 2 that passes through the point 0, 0, okay? So, and they have it graphed off to the side over here. So they're basically saying, here is your parabola, write out what the equation looks like.
That doesn't help
Okay,
me.
write out the equation of that. So here's the deal. My vertex is at 1, 2. Where does that go into this equation at?
H and K.
H and K, right? So this would be x
Negative
minus
1.
1 plus
Yeah.
2 on the end there. Yeah, there's that. So I have that stuff, okay? There's that. And then the only other thing that I need to find is whatever A is, which is my vertical stretch or compression, okay? And that's where I use the fact that it passes through the point 0, 0. So it means 0, 0 is on that parabola, right? So this is the vertex, but then it goes through this point. So it's kind of like when you're doing a linear function and you're solving for B, right? You plug 0, 0 in for x and y, right? You plug that other point in because it says it goes through the point 0, 0.
Oh.
Yes, so whatever point it gives you, you plug that in for x and y.
So you could also use like 1. Oh, never mind, because it says the vertex is there.
Yes, yes. So you don't want to use 1, 2 again because we've already used 1, 2. So we want to put 0 in. So 0 equals a times 0 minus 1
Negative 1.
is negative 1, which squared is 1 plus 2.
Oh, I didn't have a square, but that's the same thing.
Okay. All right. So now what? I'm going to solve for a.
Negative 3. Solve all of that. Oh, we have that. Negative 3. You just add those?
Because this is a times 1. So this is like 0
Divide
equals
by negative-
0
divide
equals
by
1a plus 2.
Divide by 1. Oh, subtract the 2.
Subtract the 2, right? Subtract the 2. I'm going to subtract that first, right? So negative 2 equals 1a. divide by 1. So A equals,
What? That don't even make sense.
A equals negative 2.
No one knows.
Put it in their thingy. You put 0 there, 0 there.
Yes, but this is times A. So you can't just add these two together. Makes sense? This is 1 times A. Okay? So A is negative 2. So my entire equation of my parabola is y equals negative 2 x minus 1 squared plus 2.
That is disgusting.
That is disgusting.
I hate those. Skip that one. We don't want to do
No,
it.
this one's not too bad. Actually, the one that the story problem that's on your homework assignment is even easier than this one.
We're done.
Nope, not yet. Vertex of a parabola. I got ahead of myself when I said this, that to find the vertex is negative b over 2a, right? So you have your two pieces, your x coordinate and your y coordinate, right? Comma. So negative b over 2a is your x coordinate. Now, they write it different than I do. I say plug in, right?
Well, that's
But this is like saying plug it in, right? F of something means you're plugging it into the equation and finding the y value. So this is basically like saying we plug it in to find the y coordinate, okay? All right, it just makes more sense to say plug in. All right, so next, a baseball is hit at a point 3 feet above the ground at a velocity of 100 feet per second at an angle of 45
Find
degrees
the
with respect to the
vertex.
ground. The path of the ball is given by this thing. So all of this information up here means nothing to me because now they've given me the equation and now I can do stuff with that. Okay, f of x is the height of the ball, so I'm going to put that there. And x has to do with, these x's are the horizontal distance. Okay, so we're talking about vertical height versus horizontal distance that the ball travels, okay? This is going to be a parabola, and it's going to be downward facing, right? It's going to look like that, something, right? I hit the ball, and then it travels up, and it comes back down, and it hits the ground, okay? We're almost done. Okay? You can just stay here. All right, so that's the path that the ball is going to take, all right? What is the maximum height reached by the ball?
Vertex.
Maximum is asking for vertex, right? So let's find the vertex. We do negative b over 2a, okay? Negative b, what's b?
1.
Yep, so negative 1 over 2 times a, which is 2 times
No.
negative 0.0032. Now, do that in your head. What's 2 times that? Negative 1 over negative 0.0064. Okay, now the negatives are going to cancel out, so just do 1 divided by 0.0064. Tell me what that is. 1 divided by 0.0064.
Wait, what? What
Right.
did you say?
So the negatives cancel, so 2 times that gives me that, right? But the negatives cancel out, so just 1 divided by 0.0064.
Wait.
Yeah? So that is 156.25. Okay? But the x coordinate represents the horizontal distance. They are asking for what is the maximum height reached by the ball.
56.25.
Yeah, 156.25. They want the height of the ball.
What
So
is
that
this?
means
That's the
Plug
distance.
it in.
that's the horizontal distance. X represents horizontal distance. We want the maximum height reached by the ball, which is asking for the y coordinate, okay? So we plug that thing in.
That's gross.
Negative
Why?
0.0032 times 156.25 squared plus 156.25 plus 3 is 81.125. So, answer for A, what is the maximum height? 81.125 feet high is how high the ball goes at its maximum. Maximum height, 81.125 feet. Okay, now, how far does the ball travel horizontally? Okay, this is where we get stuck.
That's disgusting.
So, the path that this ball is taking actually looks like this, okay? He starts right here, not at ground level. Okay, how come he doesn't start at ground level?
Because you're not flat on the ground.
You're not flat on the ground. You're not hitting the ball from the ground. Where is it actually starting at? What's the y-intercept?
What if it's golf?
Your hand.
3. The y-intercept is 3. So it's touching at 3, right? And then it's going up and it's coming back down and it's hitting ground level, okay? I know that the vertex right here is at the point 156.25. That means we have gone over 156.25. And we've gone up 81.125, right? Like that's what that looks like. So it's tempting for me to, when they're asking for the total horizontal distance, it's tempting for me to just multiply him by 2, but that will only get me from here to here, right? To like the point where it's 3 feet above the ground. And I'm missing this extra little bit. So it's going to be a little bit more than double that number, right? Okay, so basically what they're asking for, this point right here is called a
X-intercept.
X-intercept. How do we find the X-intercept of this thing?
Quadratic
Yeah.
equation.
I would factor it down if I could, but we're going to have to use the quadratic formula.
Why?
I don't think any of them on your test use the quadratic formula. So I'm going to write out the quadratic formula.
Why did
Negative
they make
b
them this
plus and minus the square root of b squared minus 4ac all over 2a. Whew. So negative b would be negative 1 plus minus. Square root of 1 squared is just 1 minus 4 times a is that negative 0.0032 times c, which is 3, all over 2a, which is 2 times that negative 0.0032. Okay? All right, I'm going to type that whole thing into Jake's calculator over here. So negative 1 plus the square root of 1 minus 4 times negative 0.0032 times 3 all over 2 times that is negative 0.0064. And we get equals negative 2.97. Okay, where does negative 2.97 live?
here and
This dot that's going like back behind home plate, right?
Why can't you call this?
We want to find this one.
Isn't the same.
No,
What?
no, this is negative 2.97. This
Why-
is negative
why would it
2.97.
not
I want
be
to find
the
this
same?
one over here.
Why would
How do I
it
find
not-
this one over here?
positive 2.97.
I did
Plus is minus.
negative 1 plus this guy over this. I want to do the minus one now.
Yeah, but it just don't even worry about this because if you shift it over.
What? I mean, oh, you could. So double this, and then find and add that to it. You could do that. Yeah, is that what you're saying?
Yeah.
Yeah, we could do that. Okay. I'm just going to enter it in as the plus. Whoop. Nope, wrong. I'm going to do the minus. 315.47 is what it would be.
Why would you do it like
15. What did you do to my thing?
It's like the pointer thing.
Oh. 315.47 is the horizontal distance.
Well,
So
that's
I did
not-
the minus, and that is feet.
Oh.
Okay. Now, if I take the 1.56, or no, excuse me, 156.25, and I double it, like what Jake said, that will get me from here to here, and then I would have to add on to it another 2.97. Let's see what we get. Just for fun. 1.56.25, well, 0.25. Oh, gosh. 156.25 times 2 plus another 2.97. And this 315.47. Just like we said. Yeah.
You did
No,
it
I hate
way
that.
difficulter.
That's just the quadratic formula. You're just
No,
finding the
it's
place where it
gross.
touches. Horizontal distance all the way through until it touches the ground, 315.47 feet.
I
Perfect,
know this
that's B.
one.
Yay, there you go. Okay. All right, all done.
I know that one.
Homework is this guy. You're matching. Okay. All right, I'm gonna stop it.
know
Okay, bye people watching this video.